Hello, everyone, and welcome to Inside Unreal, a show where we explore, celebrate, and talk everything Unreal. I am your host, Dan Hutnick, and today I am joined by some of the folks from the Tech Audio team who have graciously agreed to come on the show and talk about some of the things they've been working on. So let's go ahead and get them introduced. We have Dan. How you doing?
Hey, how's it going? I'm doing well. I've got a fresh cup of tea. Yeah.
Perfect, perfect. And for folks who don't know who you are,
Oh, yeah. If you've been living under a rock, my name is Dan Reynolds. No, I'm a senior technical audio designer on the tech audio team here at Epic Games, and yeah, I've been I kind of been working. I used to be embedded with the Unreal Audio Engine team, so there's I'm no stranger to the stream. And if you haven't seen those streams, go check them out. But just realize that they're in the past and may be out of date.
perfect, perfect. And Eric, how you doing?
Hey, yeah, I'm Eric Buckles. I'm also a technical audio designer on the tech audio team at Epic, working mainly on like Battle Royale, do a little bit of dabbling now in like the editor stuff, which is what we're going to be showing today, which is the TechAudioTools ecosystem. It's a family of two plugins currently that is included in 5.6. We released the TechAudioTools plugin with the engine, which added MetaSound Viewmodels, which we'll be demoing in a little bit. And then in 5.7, we updated the engine plugin and we added a new plugin to Fab that has a bunch of blueprints, some tools, and like content. And that's called the TechAudioTools content plugin on Fab. There should be links available in the stream description and elsewhere. But yeah, do we want to just dive in and show? We've got like a minute and a half kind of showcase reel here that shows off some of the content included in the Fab plugin.
Sure, yeah, let's do it. That's so cool.
That was great. That
Absolutely love
that
that.
that music was perfect. That's the first time I see seen that video cut. Oh, nice.
That's awesome. That's awesome. Yeah, so that's what we're going to be largely covering today, folks. And if you have any questions for this team, please try to keep the questions related to these tech audio tools. As much as I know there's plenty of questions for a variety of topics, this is what these folks specialize in. There's a good chance they're probably not going to be able to answer some of your other questions. So try to keep it related to the topic at hand. But if you do have a question, leave it in brackets, question, and then follow that by the question. And we have moderators that will be going through and gathering all those questions and putting them together for us so that we can throw them at these awesome folks. But I don't want to take up too much time with the preamble. This sounds like some really cool stuff that we're going to cover here. So I think you folks have some stuff to demo, right?
Yeah. Yes. So I think we should start with the beginning. What how does sound like what are we using with in Unreal for sound? You may have heard of MetaSounds. Let's talk about what they are just to give some context, especially for folks. I know there's a bunch of folks out there who may not be super into the know when it comes to audio, and maybe they want to learn more. So if you can share my screen.
Sure thing.
And while you do that, I will just basically describe MetaSounds are um, a they're effectively, if you want to do an analogy, if you're coming from other domains, it's kind of like shaders or materials are, but for sound. And they're effectively a rendering graph that exposes a bunch of DSP for designers. So it allows you to do really powerful things without the need for a programmer. And they're kind of the UE5 way of authoring sound content, sound and music content in Unreal. So I have a quick demonstration. I want to kind of sort of show like a simple meta sound. And so I'm going to right click over here in the content browser, and I'm going to go down to the audio category. And you should see MetaSound source right at the top. Now, if you're familiar with sound waves or sound cues from the UE4 days, and also kind of today also, but like not really today, then the MetaSound sources will play anywhere you are already playing sound cues or sound waves. Um, so they should slot in really nicely with your project. And you could also, if you want to update some of your sounds, I wouldn't complain. So select the MetaSound source, and we'll just call it MSS, my MetaSound source. We're very creative today. So what I'm going to create is like a simple random select node or a MetaSound. And one of the things that I'm going to be trying to illustrate here is the analogy to like materials and material instances. We're going to be talking about MetaSounds and MetaSound presets. And that's going to be a sort of precursor to understanding a lot of what the TechAudioTools, or like maybe like a good chunk of what the TechAudioTools are going to help you with, especially if you're working on a team. So this is the graph. You can navigate just like any other graph, right click and move around. It's based off of EdGraphs, so all the like a lot of Unreal graphs that sort of operate the same. But one thing, if you're familiar with blueprints, one thing to sort of keep in mind is that whilst there may be some visual language that is common with blueprints, this is not an execution graph. It's a flow graph. It's a render graph, much more like materials. Sort of why I bring materials up is that materials is sort of a render graph, and you can kind of think of data flowing from left to right. And
Dan, if I may interject real quick,
Yeah.
you're not showing the MetaSound.
Oh, is it? Oh, sorry. Let me dock it there. I forgot where it's the whole share screen thing. Thank you.
Yeah.
Derek?
Didn't want to let you get too far.
No, but it's good. It's good to keep in mind in case I open up other MetaSounds, I got to dock them with the window. So yeah. Cool. All right. Where was I? Right. Yeah. So it's a flow graph. One of the big differences between materials and audio, MetaSounds audio, is that audio is very time oriented. And so we have a couple extra features that help us manage events over time. That's where it can look like an execution, but not really be an execution. But anyway, we want to play a sound. And our sort of fundamental sound content is a wave asset or a sound wave right now. And so I'm going to just make a wave player. I'm going to zoom in here so you can all see. I'm going to make a wave player. And I'm going to connect this mono out audio output. This is the audio output of the wave player to the output of the MetaSound graph. And what that means is when this is playing, rendering the sound asset, it's going to render that out through this this connection, and that will leave the MetaSound graph. And then when we play it in the in the game or project or whatever, that will render out to the audio device and the audio engine, the greater audio engine, basically. What's cool is just like with materials, we could use this audio for something else. It doesn't have to leave the sound source. So it's a very flexible environment to build things in. Now, I'm also going to connect this on finished output. This is what we call a trigger, which is it feels like an execution. It's not an execution, but it basically is a event marker in time that allows us to communicate timing critical events to other parts of the graph. And so I'm going to take this and I'm going to plug it into this unfinished output. It's not a mistake that these are named the same thing. And the idea here is that when this wave player is finished, it will send out this trigger data, and this trigger data will leave the graph, and this output will communicate to the audio engine. This sound is done playing, and it will do all its stuff to sort of clean up resources, etc. Similarly, we're going to take the on play trigger, which is triggered as an input into the graph from the audio engine. And I'm going to take that trigger and I'm going to put it into the wave player that I have here. So what's going to happen is when I press play in the editor or I play this MetaSound source in my project, this trigger will send out trigger data to the wave player, which will tell it what timing to play the wave sound that it is referencing. And it'll play that. It'll render that out to this mono output. And when it's done, it'll indicate to the unfinished output that, hey, audio engine, I'm done. Let's go. So yeah, that's sort of like the life cycle of the MetaSound. And I'm just gonna grab I just like here one kilohertz sine ping. So this is like a test tone. I think it's an engine content or something like that. Just so as like a quick demonstration, we can see it playing and hear it. That was exciting. Okay. Does that have hold on a second. Why am I getting, oh, I'm getting feedback through the stream. Okay, that was confusing. All right. Cool. So yeah, so we've got this ping working. That's fine for games that have nothing but 1 kilohertz sine tone pings. But let's say I wanted to randomly select some wave content from some wave content and just play a single one selected element. This is like a really common behavior in interactive sound design. And so what I need is an array of wave assets, and then a node which will help me select randomly from that array. So if I right click and I search random wave, I see a wave asset array, and now I have a node that references a wave asset array and will output a selected reference. So I'm going to take this on play. I'm going to plug it into the next here. And let's promote this to an input. This will be important later on. So we want to select input and not variable. Input basically becomes a kind of interface for the MetaSound, much like a material instance input would be, or like an object that you've created. It's kind of like a public accessor. So let's name this wave content, and we will output from this value output to our wave asset input. Actually, let's just clean this up, just make it very clean, and we'll just clear this reference here, just to sort of tidy things up. And now we can put something in this wave content. Now we could just replace it with our ping and have only one element in our wave array, and we should be able to verify that it works. But I think what we want to do is actually put a set of content in here. And so if I actually, let me go to we want to keep everything docked. So I have here a bunch of footsteps from project. We've got sand footsteps, we've got water footsteps, and these rock footsteps. So I want to take these rock footsteps. I'm just going to sort of select them and we'll drop them into the array here. And now I should be able to might be a little bit quiet. Is that audible?
It is. I can also boost it a little bit for.
Yeah, if you can give it a little bit of a boost, that'd be fine. That way we can knock their socks off when I get something loud.
Yeah.
So this is great. Like this is a very simple MetaSound. You know, maybe we would want to do something like we could add a scalar to the amplitude by multiplying the value here. This is where I could have helped you out with a boost of my own, right? Like I could say, well, let's make it twice as loud.
Go for it. I brought it down a bit.
We can make it 4 times as loud. Or we could just make it real quiet here. Let's make it 4 times as quiet here.
Barely picking up on the
that's right. So one thing that we like to do in audio is we have these repeating sounds. Part of what we're concerned about is the sort of natural presentation of sounds. And so oftentimes, not only will we have a variety of variations, that's nice. That's not redundant. And we will also pair that with what we sometimes call modulation or varying processing to the sound as well. So, for example, we could just grab this on play. This is another reason why you can sort of see this is not a trigger or not an execution. It's something else. I could just reference it all over. And here, let's say we want to do a random float value, right? Random float, and then we'll feed that into our scalar here. So let me zoom. Sorry, well, I'm gonna shift there. We're gonna zoom back in, so we get a little bit easier for folks to see. So when we play, not only will it select a random wave asset and then play it, but it will also randomize a float value, which we will use to scale the amplitude of the sound. And that amplitude means louder or quieter. And so let's say we could have a really, wide something. Let's go 2 and maybe 50%, like so 50 to 200%, right? And every time I'm playing it with the space bar here, every time I play it, it's going to pick a new value. And we can even, well, I turned off tooltips, but if you hover over this output node, you can actually watch the value. Make sure your tooltips are on. So what I would like to do is sort of enhance this input interface. I talked about this input interface where we have the wave content as like an input into the MetaSound. I would also maybe add this range as inputs, and we could say like volume min, and make the max as an input, volume max. Cool. And so now we can define, not only do we have these knobs on the graph that we can sort of audition different ranges, but we can also define these values here in the details panel when I select the parameter. So here I could set the default maybe for min to be something less noticeable, maybe like 0.85, and then make max something like 1.05. So, 85% to 105% volume. So a much narrower range. And then let's also affect another really common one is affecting the pitch of a sound. So what I'm going to do is I'm going to sort of grab these, pull them back, and you'll notice that we have a lot of other like ed graph features like reroute nodes. So like I could do a reroute node here, reroute node, sort of make space, clean up the graph. We've got a lot of the graph alignment. So like here I hit Q and it sort of straightens the wires. But what I want to do is I want to make some space for another random float. And maybe I'll just reuse this this trigger. We'll go random float. And so I'm going to randomly select a pitch range. And you can see this sort of pitch shift value here. If you hover it over at home, you'll see a tooltip that will indicate the units, which are semitones. Semitones are a very useful pitch unit for music. And so if I were to say, put a 1, like a 1 here, it'd be 1 semitone up. And if I put a -1, it'll be 1 semitone down. But sometimes for sound, it's a little bit easier to think about sound pitch as like a playback speed. So like a scalar again. And so what I'm going to do is I'm going to use a conversion node to convert from what I want, which is a scalar value, into semitones. So I'm going to right click. I'm going to search for semi, and I see there's a frequency multiplier at a semitone conversion node. And so I'm going to plug in my value and I'll have the semitones coming out here to the pitch shift. And maybe I'll pull this back a little bit more to make more space for that nice little conversion node.
Having those conversions just built into a node is so nice.
Yes, yes.
Not
especially
having to do that math on the fly.
right? Especially when you're doing unit conversion, which is like such a pain in the butt. But there's another thing that comes up a lot, and this is also part of what this conversion node is doing, is it's not just unit conversion, but it's scale conversion, right? So a lot of audio has nonlinear scales. A lot of audio dimensions have nonlinear scales, and so that is also sometimes something that's useful if you're looking for like a sweep or some sort of movement that is perceptibly even across the range. You may need to like convert it to like a logarithmic scale or something like that, right, behind the scenes. So yeah, and then what we'll do is maybe I'll do like some tests like we did before. Let's do half and double. So what this is going to do is when we hit play, it'll randomly select some value between 0.5 and 2, and it'll convert that into semitones. And then the wave player will actually render the sound faster or slower, affecting a change in the pitch. But it's important to understand that this pitch shift input is not describing a time stretch. That's a different kind of process. And that would be where you're maybe changing the length or you're changing the perceived pitch of the sound without changing the other dimension. So if you think of like the duration and the perceived pitch of a sound, the faster you play it, the higher the pitch, but also the shorter the sound, right? Because you're playing through it faster. Likewise, when you play it slower, it's longer, but the perceived pitch is lower. So this is basically what we're doing with pitch shift, is we're just speeding it up or we're slowing it down, which means that the sound is going to be shorter or longer respectively. But there's another kind of process which sometimes you call pitch stretch or time stretch, or pitch and time stretch, because they're related. And that would be where you're sort of managing the pitch, but you're trying to make the sound stay the same length, or vice versa, changing the length of it without changing the pitch. And that is a different kind of process. So this is a very simple, and what's important to understand is when I'm describing those two things, this is very cheap. It's like the volume scale and the pitch shift is like a very economic way of creating variation, while a sort of time stretch tends to be a little bit more expensive. Okay, so here I've got 50 to 200% speed, and I'll play it. And you kind of hear the fast ones. But the thing is that because the content is mostly noise, because it's Rock's footstep, there's not a lot of tonality to it. And so we don't actually notice the pitch as much as we sort of notice maybe the sharpness of the presentation of the sound, because it's faster or slower.
Do we still
Cool.
have the low multiplier on that? I'm having trouble hearing that audio.
So again?
For the multiplier that we did for the amplitude for the audio.
Yeah, that's still on,
that's
but
low?
I've narrowed it. I've narrowed the range, so it's a little bit more constrained in terms.
Just a bit quiet.
Okay.
Yeah, sorry. Yeah, yeah. I went back to a more reasonable.
No, you're good. I was just making sure that
range.
they could hear it.
Yeah, that's a good one. Yeah.
There we go.
Yeah. Yeah, and something that I think, you know, we're not going to be going into this presentation, but volume management is a huge part of sound design and presentation. And so, and in interactive environments, a very challenging problem. And so, yes, what I would suggest is when you're sort of tuning those volume ranges, to think about balancing sets of sounds together before thinking about the overall presentation of those sounds, because you really want to determine that when it's in context of everything else happening. Yeah. So in isolation here, we won't worry about it.
In a lot of instances, games will like prioritize and like artificially increase or decrease the volume for things that are important, depending on what's happening. Yes,
and that's where we have post-processing effect stage, where you can add what we call dynamic compression, which will sort of compress the amplitude range and manipulate it in one way or another. And there are a lot of really great features like user settings that some games will do, where you'll have like a high dynamic range environment, like for like people with massive theater sort of spaces, or you're like low dynamic range for folks who are like on a TV set in their apartment at midnight, like sort of trying not to wake up their neighbors. Like, so there's, some cool things people will do to provide, because this is very interesting about mixing. I don't want to get too deep with that, but like the mixing is also heard in the context of the user's listening environment, which is kind of crazy to think about. Something we have absolutely no control over. So,
and that is such a challenge. It
is a challenge. Yeah,
you
exactly.
Can design for like specific studio monitors or whatever, and it sounds beautiful. And
right.
You put it on your phone, and you go like, "What happened?"
Yeah, it's like the same thing for artists and graphics designers, right? Like they're like, they've got like color calibrated monitors, and they have, they've like worked really hard on the contrast range of, because contrast is basically the same thing as our dynamic range for audio, right? So yeah, and then someone's on like some, television where like the tint's like slightly off and everything's kind of green. Yeah,
there's a reason why gamma controls and HDR controls and stuff like that are at the forefront when you start a game, because you can only do so much on the back end. You have to, consider what different hardware they have.
I've also thought a lot about, like there are games, like especially horror games, will have the sort of contrast calibration where you like you go, like, can you see the figure in the dark, and then you're like, yes, although like, so. Those kind of adjustments, I would love to see that for audio, where it's like people are like, what's the quietest sound that you can hear? What's the loudest sound you want to hear? Like that sort of thing.
That would be awesome.
Right? Anyway, sort of diverting here. Let's do the same thing. We want to have this as part of our input for the MetaSound. So I'm just going to add a min. We'll call it pitch min. We'll call it pitch scale min. So we have the units. Let's let people know what they are. I'm sort of putting nodes over nodes here. Pitch scale max. And let's just make it a little prettier. This one over here. And then we'll do one of these type of things here.
This is the graph that you use for more than half of your sounds in your project, most likely.
This is such a common
bread and butter
design. And this is where I want to sort of talk about like the difference between MetaSounds and MetaSound presets and what we're looking at for presets. So what we envision is not that, like this, what I went through, we expect that to be done rarely. So creating this, what we call this topology, the graph topology, creating this topology, we expect this to be reused over and over again for different sounds. And so our thinking is, okay, we have, like if we were to examine a project, like I think we did an analysis of Robo Recall. This is a long time ago when we did this analysis of Robo Recall, which is a great VR game if you like arcade shooters. And we're like, hey, there's actually like 6 different sound designs here, but there's like hundreds of sounds, but the actual design of the sounds, the way that they behave, the way that they're implemented is the same over and over and over again. And so what we want is like a way for people to build those, half dozen behaviors and then reuse them over and over again. And that's where I bring the analogy of like materials and material instances. Material graph you use over and over again for different contexts. And the only thing that changes is the input. So we've got our sound source, and let's go back here. Here's my sound source, and we'll call it something like MS. Let's do random basic. Name schemes are really important. You figure out what works best for your project. I won't tell you what to do. But if you right click on a MetaSound source, you can create a preset. There's a little action, an asset action to create a preset. And so here I will go to where I am at here. And let's call this FS rock. We'll go random. We'll go R&D. We'll say that's referencing it, so we kind of know what we're referencing here. But so now if I open up this MetaSound, oh, actually, no, this is fine. I mean, I could have done MSP now that I think about it. What do y'all do in Fortnite for presets? You give it a different prefix?
No, we use MSS.
Like okay, yeah.
MSP is a patch.
It is. Yeah, exactly. Yeah. So what we have is actually like a locked out. Like I can't manipulate this graph. I can't do anything. But it's what it's showing are the inputs.
Docket.
Oh, sorry. God, thank you. Yeah. So here's I've opened up the preset, and I have no ability to manipulate this graph. I can convert it from a preset to make a new sound source, but effectively it's like a MetaSound source that has embedded in it the MetaSound that we just created. This MetaSound node is actually our MetaSound source, and we could use that MetaSound source in other MetaSounds. So you can embed MetaSounds inside MetaSounds.
That's where the meta part comes from.
That's yeah. Don't call it metaception. That's banned. I won't tell you why. So here we have, if we look at the inputs, we have we can see all the values that we had in our parent graph, our template graph. But we can also override. You'll see an override flag. And so we look at these, we can see the default values. And what that allows us to do is it allows us to selectively override the parameters that we feel need to be altered for or tuned for this particular context. So in this case, what I'm going to do is I'm going to override the wave content, but not change it, because the rocks are actually what I want. I want this rock footstep sound. And what that allows me to do, so we can audition it, just like the source, the original source. This is not the original source. Forget about that. That's the future. Later part of the thing. Here's our source. We can also double click on it, which is cool. And so now what I can do is I could actually clear this out. I could trash this, clear out my wave content in the original one and save it. And here I will still have that wave content because this is the override values now. And so now what I can do is I can go to my I can go make another one. What I also had sand and I had water. So let's make the water one. So I'm going to right click and create a preset. And I will use the same sort of naming scheme here, except I'll sub rock for shallow water. All right. And let me open it. And now if I go to the wave content, there it is. It's empty. It's ready for me to override it. I can override it. I'll go to my water footstep set. I will go to and drop it in the array. And now just save it. Now this might be a situation where I'm like, oh, the pitch is too wide. I need to narrow that down. So maybe I'll go to the pitch scale max, override the value, and I will rein it in to maybe 1.2. And then the min, instead of half, I'll go maybe 0.95. So it's a much narrower pitch range. And so there won't be as much variation in terms of the sort of shape of the sound, of the length. Remember, the pitch changes the length as well. So there you go. So that's the idea. And you can imagine just like randomly selecting a sound is like a huge chunk of sound implementation. And so, but you could also imagine like maybe you've got basic music design and you have a graph that expresses that, but then you have like maybe a dozen different variations based off of different music recordings that you actually incorporate in, or some tuning to the parameters of the graph. So that's the sort of what are MetaSounds, what are MetaSound presets. And I think maybe this can kind of like, you can imagine in a project where you let's scale this demonstration up to maybe 1,000 very different MetaSound presets, or maybe like a dozen or 2 dozen different template presets. And so what we found is that different kinds of ways to accelerate our workflow and sort of enhance the utilities available to designers to help mitigate like at scale problems. And so that's where I think Eric will maybe take over to talk about editor utilities and editor utilities with MetaSounds and sound design. So yeah.
Perfect.
Yeah. So as Dan mentioned, like when you have MetaSound presets that are built from graphs that have kind of their own custom interface full of inputs, and you have a lot of these, right? So we want to make tools that are make it easier to manage them at scale. And if you have the TechAudioTools content plugin enabled, this is available on Fab, as I mentioned. I've already installed it and restarted, so I don't have to go through all that. But once you have that, inside of your MetaSound, there's a couple tools up here at the top on the toolbar. These are from the Fab plugin. And so one is a metadata editor. And so this will let me see that Dan did not put any documentation on any of his. Dan made this kick drum that we're going to be playing with today.
Which is serendipitous because I just saw someone in chat saying that they can't wait to use this to make a drum kit. So
yeah, totally. So if you're trying to make a project and you got a lot of sounds and you want to document these so people can have tooltips on each of these knobs, and tooltips are disabled. So I would just put a display name here like bass drum. You can put a description. You can mark it deprecated. Basically anything that has to do with like the MetaSound metadata is editable in this tool. Just about everything. There's some things that aren't quite in here yet, but the same goes for all the inputs and the outputs. So I can select an input, give it a display name. Like the LPG is a low pass gate. Maybe we want to actually call it that. And maybe give it a description. You can also mark it as advanced, which will hide the pin when you use this MetaSound node inside of another MetaSound. And you can also change the sort order. You can do it manually here, or this is actually the real reason I made this tool, was so that I could have an edit sort order tool. And so anyone who's familiar with trying to customize the ordering of pins on a MetaSound knows that it can be a pretty big pain to try and manage all of your sort order numbers manually. So this tool, once you're done, let's say we want the on play at the top. Maybe we'll put all of our tone at the top and then pitch. And you get the idea. And then you can click reorder. It's a little bit funky because of my scaling at the moment. So I reordered it and it applied all of the sort orders here. And now if I were to place this bass drum on another node, the pins would be in order. You do have to, it won't refresh unless you close and reopen the MetaSound if you're like editing here and you already have a node on your graph. Did I just do all of that without docking the tab?
Yeah, but I didn't realize that.
I was looking around for
I just realized, yeah.
I think,
okay.
Yeah.
Well, okay, let's redo this. So I've got this tool that I opened from the top menu. As I mentioned, we've got a section here that's all the document metadata that you can modify over here. You saw that I did fill this out, and you probably saw that update while I was doing it. It'll update it in real time. And then I did the sort order editing is this little button up here, which lets me drag and drop things, reorder them.
That's awesome.
You can click here to commit the changes, and now all of the sort orders have been applied to these inputs. So it's very useful for when you're trying to make your nodes look pretty, give them nice tooltips and descriptions. And you'll see like the icon shows up here. You can hover it and read the description. It'll show you if something's an advanced pin or if it belongs to an interface with tooltips. Again, I'm trying to show them. And display names will also show up as like a dimmer color in the list here. So it's really easy just to kind of get an overall look at your node's documentation. All right. Next one is the input migrator. And so this is a utility that you would use if you have like an old preset graph that you're trying to move away from because you have a new graph, but you want to keep the old one, so you don't want to like change everything. This is a useful tool to have in that case, where you can specify the current MetaSound that you have all of these input values, and I can show what the current values are if I hit this button at the top. And then let's say I have a new MetaSound, which I only have this one. What I can do is I can link these inputs to the inputs on my destination by selecting them, and then I can click Link Selected. So we can see we've got links. If you hover it, it will show the tooltip of the corresponding linked input. And if I hover it and select it, it'll show the link. And so then I have two options here. I can overwrite the destination inputs, which just copies the value from the source MetaSound into the destination. And so if I do that, you can see I've got 0.5 on this one. Maybe it's kind of hard to read, but as soon as I link these inputs, let me unlink it and relink it. If I overwrite the destination inputs, now you can see that value just updated. Or what you might want to do is create a preset of this destination MetaSound, in this case, my MetaSound. And that's going to create a new asset at the location where the destination lives. So now I've got a new MetaSound preset, and my volume default value has been copied over from the old MetaSound. So that's a very useful tool. I guess the other thing here is you can save your links. So let's say that you've done all the manual linking of inputs from one side to the other. You can save the links, and that's going to create asset user data that's editor only, and it's stored on the destination MetaSound. So then if I had a preset, which I'm going to make real quick, of this bass drum, and if I put that in here, it's going to already have that linked up. So let's clear it out so you can see it automatically links because I saved the data earlier to the parent.
Nice.
Yeah. So those are just a couple examples of the editor utilities. These are all blueprints, and they're included in the TechAudioTools content plugin. So you can actually just open it up and see how this tool was put together. There's a bunch of like smaller widgets that are composed together to make the larger one. And we'll take a deeper look at some of the blueprints later, but I do want to draw attention to the top left corner here, where I have a View Models tab. And I was able to get this by enabling the UMG View Model plugin, which I believe was shipped in UE 5.4. So it's relatively new, and we added MetaSound Viewmodels in 5.6, and then currently we're showing stuff that's in 5.7. So in the window menu, you have a view models.
What is a view model?
Sure, yeah, that's a good question. So a view model is essentially, I like to think of it as kind of like a data interface for a widget almost. It's not quite an interface, but what we can do with the MetaSound view models is expose the inputs and the outputs to a UMG widget. And so we can bind UMG widgets to control the default values here, just as I've been controlling the metadata. That's all been done through UMG view models with the MetaSound view models and TechAudioTools. So let me show you an example here of what a view model gives you. And you can't see this, can you, if I open this menu?
No.
That's a shame. Okay, so the view model button here will show you all of the view models that are available in TechAudioTools. There's a lot of them, and we'll go over the important ones. The first one being this MetaSound editor view model. As the name suggests, it's an editor-only view model that has access to data that's editor only, such as the descriptions and the display names. Those aren't data fields that are inside of a runtime MetaSound, but there is a runtime MetaSound view model that you could use if you, for whatever reason, wanted to have like tooling inside of your like a test build or something. Those are available. And so kind of back to what a view model is, you can see I've got all of these different pieces of data, and there's these arrows that indicate kind of what bindings are allowed to use with each piece of data. And so for instance, if I don't think I don't want to show the bindings for this. It's a little overwhelming, but here we go. This is what this is what the view bindings tab looks like once you in this very complex tool, right? So we've got a lot of them. And we'll be going through like a simplified setup of like how to set up a binding for when we're setting up a preset widget. But for now, I just wanted to kind of explain what a view model is doing. You're getting data from a MetaSound using the view model, and you're binding it to widgets using these view bindings.
I think one thing that is like there's a couple, like I feel like there are a couple of takeaways that can't be understated, which is part of the TechAudioTools content plugin that you can download now for free on Fab, is tools that are actually useful. Like these are things that you could use with your team or on your project that are just ready to go, like the input migrator or the metadata editor.
Mm-hmm.
And also great demonstrations of like a solid tool, like how to build a solid tool with all the stuff that you need so you can do it all in blueprints and UMG. Like that's pretty amazing, I think. And so I feel like that, like, yes, this is a lot of work, but if you were going to embark on a like 5-year dev cycle, this is not, this is not a lot of work for a tool that's going to empower your team for years. So this looks like a lot, and you can use it as it is and take advantage of all this work that Eric's put in. But also, you can look at it as a model for how you could build your own cool tools to accelerate your team's workflow. Yeah.
So what you gain by doing all of this binding work is a reduction in the amount of blueprints that you have to to write blueprint nodes. I guess maybe another way to put it is that the MetaSound Viewmodels allow you to modify the inside of a MetaSound using UMG widgets. And we'll dive into the code and kind of how that's how exactly that's set up and how much work it's actually doing for you, so you don't have to go and do all of that work yourself. Because there's a lot of plumbing work that's been done to make it drag and drop, basically, so you don't have to go in and bind to delegates from the editor to receive when somebody's changed the value, and vice versa. So I guess next on the agenda, we wanted to talk about preset widgets, and Dan has a pretty epic one.
I do, yeah. Yeah. So when Eric was talking about these tools, one of the things that I thought would be an interesting exploration is a tool that or a MetaSound that could demonstrate a whole bunch of things. And like one of the things was just like, hey, let's have a more substantial example of a preset widget design. So the parent graph that this preset widget sort of manages is a little bit more extensive than our random sound selection. And also wanted to play around with the idea that because the interface, the widgets are UMG, there's an intermediary blueprint layer. And so I thought it would be kind of interesting to think about the authoring environment and how that could be enhanced with blueprint functions, right? Like, so instead of just manipulating a single parameter, I could maybe manipulate many parameters at once with one touch. And so that was part of it. Part of it was just I think it's a really fun design to support parameter randomization in a synthesizer. I like synthesizers, and I think randomizing parameters is like an underutilized potential feature for synthesizers. And then the other thing that I thought would be kind of fun is extending our idea of MetaSounds to a like wave authoring environment, like a sort of proxy for like your synthesizer or some VST in your DAW that generates wave content, recorded content. So there's a lot kind of going on here. So buckle up. So here's the preset generator. If you go to the before we get into that, if you go into the TechAudioTools content plugin, you'll see a tools directory, and inside that you'll see a sound generator subdirectory, and then you'll see the MSS SFX generator MetaSound. And if we just open that up, you can kind of see the original MetaSound. It's a single oscillator synthesizer or single tone generator synthesizer, but it has the power to switch between different oscillator types. And it has a spectral effects section for manipulating the timbre of the instrument, and then also has a temporal effects section for and a dynamics effects section. So the temporal effects are delay and reverb and stuff like that, sort of. So basically, it's like a synthesizer with a bunch of effects and a bunch of modulation potential, pitch modulation, amplitude modulation, with LFOs. And if this is all going over your head, I understand.
I followed almost everything until you said LFO. That was the one that I didn't catch.
LFO is like a low frequency oscillator, and basically infrasonic or subsonic. Like, you can't hear it. It's so slow. But those kinds of those are very useful for creating movement and shaping parameters over time, right? So there's kind of a lot going on here. I would say from a like I have a lot of experience with synthesizers, and so designing this was not too much trouble for me. It was actually a lot of fun. Um, but this can be incredibly intimidating for someone, especially if they're new to synthesis or they maybe have a loose grasp or no grasp on these varying these different elements and sections. And so oh, and this is another thing that happened. Sometimes we call this like a larger sized meta sound. Sometimes we like colloquially call it a mega sound. But but there's a lot going on here, and sometimes what people will do, like designers, happens a lot, is they'll sort of duplicate the input and then sort of organize it in some way to help them sort of tune parameters. And so this is all very common. If you've already worked on a project and you have some larger meta sounds, this kind of thing is not you see comments trying to tell you what's going on and inputs sort of gathered in one spot. So yeah, this to me is sort of the sort of use case that I wanted to tackle. And yeah, sorry, go ahead.
No, I was gonna say it's so interesting to see this kind of thing broken out in a node structure where I'm used to these tools being, pretty opaque, where you don't have a lot of
Like a
visualization. It's
keyboard.
just knobs and dials and stuff
Yeah.
like that. To see this like broken out this way is actually really fascinating.
Well, this is what I talk about the power of MetaSounds, because it's like just exposing this DSP to designers, and if you know what you're doing, you can do some really powerful stuff, and if you don't know what you're doing, you can always learn. You can always learn. But what I'll do is I'll actually create a new preset. So let's do our thing. We right click on the template, our parent object, the thing we want to, and then we go to the asset action create preset, and let's put it somewhere else. Let's put it in. We'll put it in my dev folder here. So I'm not going to name it anything fancy, but I will save it. And will it dock? So here, look at this. This look at this. Like this is unwieldy, right? It's like not fair. And I've tried to organize the inputs. I've got this namespace thing going on, so you kind of see how there's like categories and groupings and stuff like that, right? I've tried to do this to
Can you mention how you did that?
Yeah, so the way that you do that is actually just using dots. So if I go to the original one, let's say we go to this attack, which is this parameter, you can kind of see it highlight when I grab it. You can also search for the node on the graph. But yeah, so I have this attack parameter. This is a parameter that's used for the envelope. The envelope is part of the amplifier management or dynamics management. And the attack is the beginning of the so you can kind of think of it as like a fade in, right? How does the sound fade in? And so yeah, so this attack, you can kind of see here, if you squint and get really close to your monitor, you can see the input. I've typed amp dot envelope dot attack. And what that's done is it's organized it in these sort of groupings here in the input section. Now, this is why when you change the sort order, it doesn't show here, because the way that the inputs are organized in the source graph is by this naming space scheme. And there's a Discord notification. I forgot to turn off. I don't know why. There's too many parameters. Discord, you have too many parameters to shut off. Right, where was I? So that's how you get the name organization. That's really useful. And this, we're gonna say it here.
No, that's a pro tip.
Yeah. Yeah. It's I forget to do it all the time, but yeah, that's a really great way to organize your inputs when you're just looking at a big old list. And if we look at our preset, it's still organized that way, which is great. Like that is helpful to a certain degree. But there what preset widgets potentially open up a lot of opportunities for us, and you'll see that because I've implemented a preset widget on this MetaSound type, you can see now there's a tab, preset widget tab, and if I click over there, I wanted to say select and click at the same time, and I said slick. If I click over there, then you can see the beautiful. This is like all of my UMG skills at work here. And I even added a scroll bar because there's so many parameters. But this may be more like what people are familiar with when they think about synthesizers.
Looks great.
And VSTs. Yeah. And so I boldly called it the sound effects generator. And what I did is I kind of organized the parameters in a very similar way to how I did the namespaces. I organized them by groups and subgroups and parameters within subgroups. And so what's nice about this organization is when you're trying to tune one particular part of the design that that you've got all the relevant parameters right next to in proximity where you're working. So that's like a good reason why. And so that's what I've done here. And if I play this, I've got the default sound, which is just like a a little square wave. One of the things that I wanted to do as part of taking advantage of UMG and blueprints and the larger sort of Unreal Audio feature set are these analyzer windows. So, for example, you can see this little oscilloscope, and so when I play, you can see each of these oscilloscopes sort of lighting up and showing a waveform, and these all are representing parts of the signal flow, analysis of the signal flow in that area of the MetaSound graph, the original MetaSound graph. And so I thought it would be a really interesting way to provide feedback to the designer to sort of see, hey, how is my waveform changing across these processes? So, for example, let's say I wanted to make it take longer. And remember, I talked about that attack parameter. So let's maybe increase the attack. This is going to increase the time that it takes to go from 0 to 100% volume. And now, we've got like a really long sound, and it's got a long attack and what we call a long release, which is the time it takes to go from 100% to, or the sustain level to 0. So yeah, there are different ways to sort of look at what's going on with the graph, and then I could add, like, let's say I wanted a shorter sound with no attack and a very short release, and then we have a boop. But I could do things like let's add some reverb to it, or I could add a delay, which is sort of like an echo effect. Well, let's maybe we could make it take a little bit more like that. Yeah, the timing of that is based off of the duration. So. Okay, so you kind of get the idea. And each of these, and so what I liked about doing this was lowering the intimidation factor. In other words, something that if anyone wants to get into synthesis, and you're looking at a synthesizer, you're looking at all those knobs. Part of what synthesis, the sort of philosophy of it is like, an invitation to explore. And so you look at this set of knobs, and if you're trying to, tune for a specific sound and you don't know much about synthesis, it can be a pretty challenging, right? Like I could sit here and lower the sound and change the waveform to a triangle, and adds all these sort of features. But you can also just play around and just see what happens when you change a knob or you change a parameter or turn something up or down. And I think giving that feedback so you can see where the sound is changing along the signal path, or feedback to what the thing that you're changing is doing, helps sort of realize what's going on. So that was also part of the fun of it. And then to sort of prove how arbitrary parameters are, I have a random function I've added to every knob. And every parameter group and every parameter supergroup and the whole thing. You can just randomize all the parameters if you want. And I also have a locking feature, so you can basically the randomization goes from big to small. And so if you want to sort of lock down if you want to stop the randomization at some level, you can sort of lock at that level and it will stop trying to randomize stuff inside there from outside. And so for example, I could just randomize this oscillator section, which is the tone generator part. And it's just changing what tone did I do a big one? I did a big one.
Yeah, you're doing the whole thing.
I did the whole thing. So now we're going to get all kinds of stuff. And I sort of jokingly call this like the sci-fi generator. Because you can come up with some really crazy stuff. Every once in a while you get one that's like, that's a bummer. Like that's a dud. But it's okay. You just keep going and play around. Yeah, exactly.
On the flip side, though, there was a couple there that I'm just like, I don't know, that sounds kind of cool out of the box. I don't mean.
Yeah, right. Exactly. And so, this is a way where this is sort of changing the game in terms of the authoring experience. I could sit here and come up with a whole bunch of different stuff, and I could I was like, oh, maybe that sounds really cool, right? And I'm like, maybe I want to use that in my project. All I have to do is save it, right? And just save it. It's the preset. Here it is. Or where did I put it? Here it is. Is this it?
No, it's in your dev folder.
Oh, that's right. I put it in my dev folder. Thank you. Right, here it is. It's just a crazy sound that I can play anytime I want in my project, right?
I'm fairly certain I heard that in arcade one time.
So yeah, and I've got some examples here. Some are like, for example, this kick drum was a curated one. I just went through as like a synthesist and I just set up a kick drum.
So this is a kick drum purely synthesized. There's no
purely synthesized. Raw. Yeah, this is, this you could put in like another MetaSound and then have a rave or something like that. Then I had
somebody in the chat said we're getting invaded.
That's right. So I also made some other ones based off of random. Like sometimes what you can do is you have your random, everything. That's very sci-fi. But maybe I'm like, that delay is like too much, right? So what I could do is I could, maybe rein in the feedback and the time, and I could lock this. So now when I play it, maybe tune a little bit more. Maybe that's too much, And then maybe I'm like, that's too long of a sound. So now you can start going in. You've like, this is cool. I like parts of this, but I want to change some other parts of it. And you can go through there and sort of tune the sound. And again, you don't really have to know anything about synthesis, but you just have to know when you turn a knob, it does the thing that you expected it to do, right?
And if folks wanted to, they could also do like a sample-based sort of creation, kit bashing sandbox.
Yes.
Yeah.
I think this is exactly. So what to that end, like this is this widget is a representation of this graph, right? So in other words, you build your topology, and that is the sort of behavior or DSP design of your graph. The elements that go into it that are part of the render could be synthesized sounds, or could be recordings that you bring in, right? Or some hybrid like wavetables. And so you know there's a lot that you could do there in terms of where the source material comes from and how you affect it, how you process it. And then what's important is that you can then represent that through some sort of data, some data input, and then represent the data in like a more meaningful way. So one last thing that I thought would be fun to add is I was like, what if we added also the ability to say, I like this sound, but I want to print it as a wave asset that I can reuse outside of Unreal or inside Unreal in my project, or just like bake it so that you have that and you can just play it like a random sound. So if you could play the video that I prepped, yeah, thank you. Yeah, thank you. So yeah, I didn't do like a voiceover, but basically what's happening there is I added a feature wherein if you arm this record widget, then when you play it, it will actually write the playback into a file, and the file will be saved in your saved directory under audio captures, and it'll be named whatever you put here. So I added a little text field, you know, my favorite sound or whatever. And so so yeah, I wanted to show that because way we're sharing the screen, I can't like show the Explorer, Windows Explorer, whatever. But yeah, I just wanted to sort of show like yet another cool thing I wanted to explore. And I think that, you know, that has a lot of fun work, because I really enjoy working in MetaSounds just in general. I think it's a really creative space to work in. And sometimes you're not making something for an Unreal project. Sometimes you're just making it because you want to make it, right? And so I think there's value in that. And I'll go into in depth here how I made it. But yeah, yeah, this is sort of the philosophy behind this is manyfold. So yeah.
Real quick before we move on, we had a question here. Is this so? We've shown that we can kick these out as exported printed files. The benefit of that is you could use it outside of Unreal and stuff like that. What would be the use case within Unreal? Like is this something that's performant enough that it can be run real time without too much overhead? Or
that's a
is
great
it something
question.
where a lot of times maybe you'd want to kind of kick some of these out? I assume it's based off of the complexity of the sound and how many things in the chain, but
yeah, exactly. So you know, computers come in all shapes and sizes. And without going into the price of RAM or graphics processors, that, you know, there are some computers are not as mighty as other computers, and some devices are not as powerful. And so the cost is always relative, right? The cost is always relative. If we were to look at, we try to offer some performance data. So, for example, if I play this, you can kind of see here. There's like a CPU estimation And that's sort of, it's a little arbitrary based, your computer is different from the computer you're going to be deploying on. But this is, I would say this is not a trivial MetaSound design. Like where was my random sound? This one is a pretty trivial MetaSound design. I would expect to be able to have a lot of these playing. I would not expect to have a lot of these playing.
Right.
Okay.
And I think something that's important to say is like, I mean, this is a relatively complicated looking graph, but it also doesn't look like crazy insurmountable.
It's not super. I've seen crazier ones. Yeah.
There's a lot of math happening behind the scenes, though, that these nodes are representing that has to be calculated, every play, right?
So there's audio DSP and visual video DSP, I guess, audio video. Yeah, aural visual graphic sonics. Okay. As long as the language pairing here is correct. There's a lot of, shared DSP. It's one thing to think about when comparing graphics to sonics is you can think of graphics as like slow and wide processing. So the frame rate, the update periodicity is pretty low in graphics. It's like 30 hertz, 60 hertz, 120 hertz. That's like nothing. But there's a lot. It's very wide. There's a lot that's happening every one of those frames. Audio is the inverse. Audio has a narrow stream of processing, but it's extremely fast. Our frame rate is 48,000 times a second. So that's sort of, if you think about it, like, and graphics, processors are sort of tuned to that slow and wide processing method. So we're oftentimes working off of the CPU with everyone else. And so when you think about your resources, your machine resources, that's something that you want to consider and how audio processing fits in the wider puzzle. I have definitely worked on projects. Like I've worked on a mobile project when I was your age. I worked on a mobile project when you couldn't have their app be more than 30 megs because no one would download it. And we just and the G that we were on was 3, right, instead of whatever we're on now. And so in that case, I remember I worked on a game that was like physics simulation heavy, and so I had to go real light on processing, right? And I had to find ways to do that. So it's all about your like context in the project. If you're working on some computers are like really awesome these days, and if you're working on an indie game that's just shipping on desktop and the graphics are like very retro inspired and they're not doing a whole lot of processing, maybe you got a ton of headroom, right? Maybe you could do some crazy stuff in audio, in which case having a bunch of these playing, maybe it's fine, but if you're got a really heavy game where every subdomain is like scraping for resources, then maybe you want to be a little more economical. And maybe that's the situation where that's a cool sound, but maybe we could just bake that, right? And have it as a WAV file. The other thing to think about is like, is the experience dynamic in some way, right? There's a lot of parameters that go into a sound like this. And those parameters could be influenced by gameplay, which is wild to think about, right? But is that how you want to use the sound? Like maybe you're not changing the sound that much, and a WAV file representation is fine, right? Like that, maybe if you're not doing anything to it, then a WAV file is fine. But maybe the like pitch and other things are tied into gameplay data and things that the player is doing. And that's, so that's where you sort of pick and choose your battles. Another thing that you'll find is like with larger scale MetaSounds, oftentimes they're hero sounds. And that could be like a really great way to sort of to tune things like, oh, this is a hero sound, so there's only gonna be one of these playing at any given time, and maybe this is for the player character or the local player experience, but maybe NPCs and remote players get like a reduced version of the sound. And we're not gonna go into like, there's lots of stuff MetaSounds can do to help tune like a different deployment target platforms, but that's not really like we could spend hours on that alone.
Next time.
Yeah. We'll do another stream for that. But yeah, where was I? Right. So There are some things, some concessions that I made that maybe are, we're looking at things like being able to maybe identify nodes that should be compiled out for runtime versus editor time. So I'm using some nodes in here that sort of cheat that a little bit, for better or worse. So for example, if we zoom in, we can see these output nodes. I didn't really talk about output nodes, but we have the ability to feed data from a MetaSound out to gameplay, which is kind of wild to think about. And so these output nodes are driving the ones, literally the ones right here, are driving these little progress bars. So if I play this, you can sort of see these progress bars that I sort of manipulated to receive this input are representing the value of that output. Also, the oscilloscopes are rendering from, let's see, where did I put an oscilloscope? Here. So you can see we've got this node called an audio bus writer. And what it's doing is I'm taking this audio, this is an audio buffer, that output. Remember I said audio doesn't have to be something you hear. Sometimes it's affecting something else inside the graph, right? And so in this case, this is a vibrato or frequency modulation that can occur at a high frequency. So in other words, you can change the parameter at a super high rate than just twisting knobs or we talked about LFOs as like a slow rate modulator. Imagine that at like a really high frequency. And that's where we have a whole class of synthesis called frequency modulation synthesis or FM synthesis that is from this modulation setup. But I'm also feeding that out to this audio bus, which is sort of like a buffer inside the larger Unreal Audio engine that I can then feed into an audio analyzer that's giving me the oscilloscope that you see. And you can actually see the audio buses that I have set up here in the audio bus directory. And you can see I've got a whole bunch of them, and each of these is for one of these oscilloscope views. So those are examples of like some of the design that I went into because I wanted to sort of show this rich editor view, but maybe would not be practical in a runtime version of this sound effect.
Really powerful to have that visual feedback when you're working on
Yes.
something.
Yeah. Yeah, exactly. So let's take a look at, I also another thing that you'll see, which maybe you may be surprised to learn that when we look at this graph, we're looking at the top layer of the graph. And if I zoom in, you may have noticed that that some of these nodes have blue text and some of these have green text. And the blue text, it means that it's a subgraph or a patch. We call it patch. So if I double click on this, it'll actually open another asset that is doing work. So you can sort of modularize your MetaSound designs and topologies. And it's very common for a team or a project to sort of curate a library of these patches that they can reuse over and over again in different topologies.
Kind of like your material function.
Yeah, I was gonna say, or like a function or a macro in a blueprint.
Yes, exactly. It's actually functionally it shares a lot with macros because it actually expands like a macro when this is compiled. So it's actually a lot like a macro in the way that it behaves in the graph and when the MetaSound is compiled. But it's a nice way to sort of visually organize. That expansion is not free, but on its own is not costly. But it is something that Eric has had to contend with at scale when you have very deep, when you have patches and patches and patches and patches. So you'll notice that this design is pretty flat. It's like got two tiers basically, and that's kind of how I kept things to keep it sane, both in graph organization and the potential reuse of some designs. Right. So you can see the patches all here. Here's all the patches, and But what I want to get into here is the double click here. Okay. I want to get into the widgets. And I won't go super deep into some of these because one thing that I've learned, and maybe this will change someday. Maybe it's my own inexperience with UMG as an audio designer, but a lot of when I wanted to add functionality, there's a library of widgets that Eric has already created that make this like he set up the bindings and all this sort of stuff in advance, and it makes setting up widgets really, really easy. One of the things is when I wanted to add functionality to it, like inheritance is kind of funky from my observations with UMG. And so I found it easier to just sort of copy his work and then just sort of extend it as like a copied asset, as a copied widget. So you'll see some stuff like this knob, for example, is like a copy from the knob that Eric made, and I just sort of added my own little bits for the random and lock features. But we can just sort of take a look at the main widget, and it's sort of insanity here. It's been really interesting also because if people go back and they watch the 2017 Future of Unreal Audio GDC presentation, you'll see another synthesizer widget that I made for that presentation, and that was like, so it's kind of like an interesting full circle moment for me.
Yeah.
But yeah, so you can sort of deep dive here, and there's all the sort of terrible things that inexperienced UMG designers like I do, where you have like the big flat list of like events that do one single thing. Classic. Someone at Epic headquarters is cringing right now. But yeah, I don't know how deep we want to go here. Now I think about this.
Dan, it might be good just to do one from scratch, like a simple one, like a walkthrough.
Yeah, maybe you could do that.
I'm set up for it. So,
yeah, cool.
We'll use your kick drum as the example.
Works for me.
All right, so we've got this nice fancy kick drum that Dan has made. If we play around with some knobs, we got some tonal elements to it. And I'm getting some feedback. Is that something I can...
Yeah, that's what I was also receiving.
Okay, cool. I'll just deal with it.
We've got hearing it from the other stream. You could mute that.
I muted the other one, I think.
Oh, you know what it is? It's because it's coming through the master for Zoom. Let me shift that off, and then you won't have to deal with that.
Okay, I'll keep talking. So, we've got a bunch of inputs that Dan made, and this is a synthesized bass drum, and I'm not a modular synth person, so I don't really know much about what these are doing, but I know I can move some knobs and get some different sounds. And so we're going to just go ahead and close some stuff here. I'm going to make a new editor utility widget that we can use inside of our preset. So I've created a kick drum preset here already, and we don't have a widget, so you won't see the widget tab. And if I go ahead and create, I'm looking under editor utilities, and now there's a
sub-menu.
Yep, I know. I'm just going to talk through it. So I've got a window here that wants me to pick a root widget, and I usually go with the vertical box as the root widget. And I'm going to call it EUW, thanks, autosave, kick drum preset widget.
Yeah, Eric is adamantly against Canvas as your root widget.
Well, yeah.
So all you Canvas people, get out of here.
So Canvas widgets, I think a lot of people they'll watch the UMG tutorials and they all say to use Canvas. I think UE4 actually had Canvas as like the default for all widgets. But so canvases are good if you have like a full screen HUD or something, or you want arbitrary placement of widgets. For our purpose, we're making editor tools, and so we want like responsive layout or things to scale and reshape itself. So Canvas is a pretty bad choice in that regard. So I like to keep it simple and just use boxes, both vertical and horizontal boxes. There's also some fancier ones like wrap box or scale box, size box, etc. Those ones are great. So I've got my brand new widget here, and just a UMG pro tip for making editor widgets. I always take full screen and I change this to custom. And so what that does is it fixes the DPI scaling from, I think before it was like 0.67 or something. And
6.7?
Oh no, I said the numbers. And so now like we can actually resize our widget however we want. And this will let us test how it's looking when we squish it in different formats. So after that, the first thing I always do with whenever you're using view models with editor utility widgets, you have to do this. Go into class settings. There is a box, as there are many boxes in Unreal. And if you do not check this box, it says can call initialized without player context. Your view models will not initialize. So I have a habit of just always setting this. There is in project settings, there is a setting for it for both runtime widgets and for editor utility widgets. So you can default this on if that's okay with your project. You probably want to get permission from your UI team that you can set that. I don't know what it affects on like runtime widgets. So with that, we're also going to, while we're in the class settings here, going to add an interface, and we're going to look for the MetaSound preset widget interface. I'm going to go ahead and add that. And now we've got a few different functions here that we can implement. The first one I'm going to do is get supported MetaSounds. And so this function is what determines which MetaSounds we want this widget to appear in. And to set this up, the easiest way is just to promote this to a variable. And now in the details panel, I can compile, and now I can specify the exact preset parent that I want. And so I'm going to choose the parent here, which is bass drum. And now I should, if I've not forgotten the step here, if we go back to our preset, I think I have to reopen it. We now have our preset widget tab. It's currently empty because we have not put anything on our widget yet, but this is a good sign that things are set up so far. The other functions here we've got are on MetaSound preset widget constructed. So I'm actually going to get rid of these other ones. And so we've got a builder coming from this this function or event. I could promote that to a variable. And so now we've got...
What's the builder?
Yes. So the builder is the back end, so to say, for this MetaSound that we are putting this widget into. And so it's going to let us have access to all of the stuff inside of the MetaSound. And we're going to feed this into our view model here, which we haven't set up yet. But this is like the connecting point from the widget to the MetaSound. So speaking of view model, let's go over to our designer tab. And again, if you don't have your view models tab, it's up here in the Windows menu. The first time you enable the plugin, you probably will have to go and find that. I'm going to add the MetaSound editor view model here. And I know you can't see it, but there are a lot of view models here, and I'm just searching. And so now we've got this little pop-up here that's warning us that we don't have any bindings. And for this example, we're not actually going to set up any bindings here. And so to get rid of this, we can override this message by going into the view settings. There's this little gear icon with the view settings item in the menu that's going to pop open the details panel with some options. And we want to create view without bindings. And this is just one of those UMG like optimizations. Like they don't create the view unless you need it. But in this case, we're not going to actually set up bindings directly, which you can if you want, in which case you don't need to check this box. But I'm just going to go ahead and do that. And so now, if I click on the view model at the top, we have our details panel for the view model. And I'm going to change the creation type from manual over to create instance. And there are a few other options in there, which I'm not going to go into. But create instance I use quite a bit in cases like editor tooling. Manual is good if you have an instance of the view model coming from somewhere else.
Like a sub object or like a sub widget or whatever.
Yeah, like if you've made it in a parent widget and you want to pass it on in, you could leave it as manual. I think a lot of times in like UI gameplay code, they set it manually because the view model is coming from something like a subsystem or like from the player or something. And even one of the other options in here is like a resolver class, which is a separate blueprint, which has a responsibility of resolving where the view model comes from, which is I haven't dived into that too deeply. They seem really powerful and might be able to leverage it for MetaSound Viewmodels at some point. But just know that that's available there if you want to check it out. Right. Okay. So I'm going to compile and now go back over to the graph. And so this one thing to add here quickly, when we create this instance is created between pre-construct and construct. So if I override my construct function, we will have a valid view model instance at this point, but if you use pre-construct, it won't be available yet. And so over in the details panel, we have an automatically generated MetaSound editor view model instance here. And so I'm going to grab that. And one thing you might have noticed over here in our list of available view model operations is we have an initialize MetaSound and initialize builder. And so both of these functions do the same thing. It just sets the builder on the MetaSound, or sorry, sets the builder on the view model so that the view model can set itself up and initialize and make all of this other data available for us to use. So we call initialize and then everything is available. So that's what we're going to do over here. I'm going to
So you're just going to pick one of those, right? Like you don't need to use them both.
Right, just one of them is fine.
And that probably depends on whether or not you have the builder ready or the MetaSound, like as an asset or something like that.
Yeah, so if you have a
builder because the interface is giving us a builder reference, right?
Right. So if you have like a tool that you want to reference a MetaSound asset, like in the content browser, you would call initialize MetaSound versus initialize builder. And so I'm curious why I can't call initialize on here.
I think it's not as context. Maybe it's not showing up in context menu.
Interesting. Oh, well, it might be a namespace thing actually. So because if I plug it in, one thing that I like to use is namespaces, which is good for like editor function libraries. But in that case, it's not here. So I don't know. That's confusing too. I don't think I've bumped into that. Anyway, you know how to find it now. If you can't, should be context sensitive, but it's not. So I'm just going to take my builder reference that we cached earlier, and we're going to pass it in here. And now if I compile and save, if we were to start binding things in our widget, we would be able to access all of these things. The ones that are most interesting to us at the moment are the input view models, which is going to generate an instance of the input view model for each input on the MetaSound. And we'll be able to use that to control the inputs using knob widgets. I don't think we're quite done here yet. Let me double check. Okay, let's just start by putting one of our knob widgets on the widget. So in the TechAudioTools category, there's a bunch of stuff, and some of these are like just general purpose editor utility things. A bunch of these are like MetaSound literal type primitives, and so these are like super basic, like there's no text or there's no like other functionality added to it. So if you wanted to make your own custom kind of compound widget that adds like text, how you want it formatted, like maybe you want the text below it or on the left of it, you can create your own using these as like your ingredients. But there are some that are pre-made, and I'm going to just type it in because there's a lot of them. I'm going to use the MetaSound literal float default knob, and I'm going to put that aligned to the left and to the top. And so this is going to be what we map to our inputs, and remind myself what inputs we've got here. I'll just start with the first one, which is our LPG decay. Back here on the details panel, there's a bunch of stuff that's like generic widget stuff. We can close all of that so we can just look at the stuff that's relevant to the MetaSound widget. Here is an instance of a literal view model of the float type. And this is what lets us map the range of this knob widget to whatever our MetaSound wants to accept as an input range. And I believe Dan has set these all up to be 0 to 1 value inputs. So that's nice and easy.
That's something that's a great sort of design philosophical question that I've debated lots about. I tend to prefer normalizing my input values and then mapping them inside the MetaSound. But sometimes it's really useful to not normalize your input values. Like, say, for example, if you've got a MetaSound for maybe a car engine, you want like discrete RPM values to come in and then to interpret RPMs as they come into the MetaSound graph. Whereas like 0 to 1 for RPMs is like, well, I don't know what's going on. So that's it's a great debate, and oftentimes I feel like normalizing it makes it a little bit easier, especially when you're doing stuff like this. But yeah, it's a good question.
Well, and when everything is can be controlled with a 0 to 1 range, like you can do a lot of powerful stuff with that.
Yeah.
So back to setting up this knob. Here we have an input name, and this is what needs to match the name of our MetaSound input exactly. So I'm going to go back over, and I'm just going to copy and paste lpg.decay over here. And we can give it a label, so maybe we don't want to show the whole name, but I'll just do it anyway. We can specify a default value, so maybe we want this to for when we click the reset button on the bottom here, we want it to set to this default value of like 0.2 or whatever you want. There's also the option to apply logarithmic interpolation. So if you're doing like decibel scaling or something and you want to have it scaled logarithmically, you can just toggle that on. There's also, back up to the view model here. There's different mapping types. And since we're just doing range 0 to 1, I'm just going to leave it as default. And you can also specify units. These are just cosmetic. It'll append the number with like the unit label. There's also different mapping types in here, including map range. So if you have a range in your MetaSound that's different from what you want your knob to display as a range, right, you can remap that here, and it's just a linear remapping. But then there's also volume and pitch is kind of like special cases where maybe your MetaSound wants linear gain, but you want to display it in decibels. This is a pretty common preset for widgets that we want to control volume with. And then pitch converts between semitones or frequency multiplier, as Dan had done earlier. Yep. So play around with those and figure out what works for you.
A lot of those last two, I feel, are great for depending on like thinking about your user. You know, when you're designing this, oftentimes you have like a specific user in mind, and is that person like deep in the audio domain, maybe decibels and semitones are appropriate, whereas maybe just a linear scaler is the easiest way for someone maybe coming from a more generic background.
Yeah.
And that would be an instance where like a description could say like, hey, 0 is X and then 1 is Y, so that for those who do want to have a little bit more granular information on what that represents.
Yeah, so this widget will actually grab the tooltip, the description of the input. So if you hover over this node later on, which I can't show tooltips, but the description will be there. And so if you've marked up your widget with descriptions here, like the example from earlier, that will show up when I hover over the knob inside of the preset widget, which is really convenient way to document your preset widget so your designers can know what the range should be or just know what the parameter is for. So back to the last couple things here, we've got a display format, and this is specifically used for like controlling the number value. Like if you only want to show, if you don't want to show any decimal points or digits after the decimal, the fractional digits, you can set the minimum to 0, and then it'll just round up or round to the nearest fractional unit. There's also like if you want pluses to always show, if you're using decibels or something and it's positive, you can do some stuff there just to control how it's formatted. And then lastly, which is kind of my favorite, is you can change the color of the knob and make it look a bit more custom. So maybe you like some colors like this, design it however you want. There's a lot of other ones here. You can get a little crazy. I usually just change the oh, I guess you can't see my color picker, but that doesn't matter, I guess.
I can't see the color picker.
Yeah.
I'm just a color picker.
Yeah, I'm just picking color.
We have a question in chat that asks, where's the button that makes it go to 11?
Well, so you could just change the range here up to 11, and now, well, I guess you'd probably want to remap it, right? So you do like a map range, set it 0 to 11, and there's your 0 to 11.
Yeah.
So we've thought of everything.
Love it.
So now that we've got our widget on the widget, I guess we now need to connect it up using there's one function that we need to call. So I'm going to make sure that I tick that this is a variable up at the top. And so now on my graph, I can grab a reference to that widget. And this is another function we're going to call, which is a set literal widget input view models. And so this is a function library function that we'll plug in our view model into. So I'm going to copy and paste that over here, plug it in to our function. And then this should let me plug it in here. And we'll come back to this in a little bit since we've got more knobs that we want to add. But for now, I'm just going to make sure that the first one is set up properly. So what this is going to do is it's going to search for the input name that we've provided here. It's going to find that inside of our MetaSound view model, and it's going to set the view model for that input on the input widget. So there's a little bit of like view model inception going on here, but if we've set up everything properly, we should now go over to our widget. We've got a knob, and I see it's properly received that value that it was originally at. And I'm going to pull up on the side here just so we can see that when I move this knob, that we are indeed going up to 11. And I must have forgotten to set that back. Did I compile?
The mapping.
Yeah. I should have just done map range. Let's go to 11. Okay, there we go, up to 11, but our value down here is set to 1. So the mapping is working just how we like, but we've got more inputs to work with. So let's go ahead and very quickly just, I'm going to copy and paste this, I think, and then we'll just update the properties. And so since I'm using a vertical box, they all went vertical. What I can do is highlight all of them, right click, and we're going to, you can't see the menu, but there's a wrap with option, and then I'm going to wrap it with a horizontal box. So now everything is nice and horizontal. What I could do instead, though, actually, is a wrap box. So I'm going to right click, replace the horizontal box with the wrap box. And now what I can do is I can specify the inner slot padding. Since these are all kind of too close to each other, I'm going to spread them out maybe like 16 pixels or something. And now we've got a little bit of padding in between there. You could also do like, you could fill it like evenly across the whole width of the widget, or like have it centered. A lot of cool things you can do with the wrap box, but I'm just going to leave everything just top left for simplicity. Okay, so now I'm just gonna, I guess I can't undock it, but we can just go back and forth and copy paste a bunch of these. This is our pitch. We've got decay. And I'm not going to bother changing all the default values. We'll just roll with it.
Yeah.
We got pitch mod. Dan, do you want to talk maybe a little bit about what each of these parameters
Yeah,
actually
sure.
do?
Yeah, let me see if I can. Let me. Okay, that's a little bit harder to see here. Let me. Do I have it? I don't have a local version. Basically, um, so the kick design will have. So I'm trying. I'm going straight from memory. So when I'm making a kick drum, there are a few components that I like to put in to my design. One, I want a tonal element, and the so that will be like an oscillator, a simple oscillator. I'll usually go with a triangle or a sine wave oscillator. And the reason is because those tend to be a little bit more gentle. And what I'll do is I'll after the oscillator stage, when it's outputting the oscillation, I will add a wave shaper node. The wave shaper node allows you to sort of simulate a drive function. And what that lets me do is use the wave shaper to go between a more uh, uh, like a less aggressive tonal sound to a more aggressive, more squared off sound. So that gives me some timbral features. If you have a sine wave, as an example, sine wave from a harmonics perspective, timbre is the description of the harmonics of a sound source. And that's the frequency content that represents like the fingerprint of a sound. That's why if you play the same note on like a piano and a violin, they sound like different instruments. You can identify one as a piano and one as a violin because the timbral quality of the sound, the overtones, the harmonics in the sound, imbue a character to the sound that distinguishes them. That's why our voices sound different from
Two
one another.
people doing the
Yeah,
same.
exactly.
Yeah, exactly.
So, synthesis fundamentally is subtractive synthesis, which is the sort of area synth domain that a lot of the demonstrations we've done this stream are focused on. Is where you start with a harmonically rich sound source and then you sculpt that away with filters, which remove harmonics, or an amplifier, which allows you to manage the amplitude of the sound presentation. And then we have different modulators, which shape the sound over time. And so for a kick drum, I like to have three different sound sources. I like to have um, sort of like a sine wave or a triangle wave, which is sort of a more gentle starting point, but then the wave shaper allows me to make it a little bit more aggressive sounding. And then I like to have a noise source, which is noise is a non-tonal source. If you think of someone sort of shushing you, that would be like a noise type sound that doesn't have a lot of tonal content in it. And then I like to have a sort of impulse or a transient, a click sound. And so if you look at the kick drum graph, there'll be those three different sound sources. There'll be a oscillator, there'll be a noise generator, and I'm actually using an envelope generator, which is normally used to shape the amplitude of a sound over time or to shape some parameter over time. But I'm actually using that as a sound source for the click. Um, and
Mm.
and so you'll see noise, click, and frequency as like inputs, and the or pitch as inputs that I sort of allow people to tune. And then one of the things that allows you to create a drum-like sound with this particular approach is to quickly modulate the pitch of your tonal element. You can kind of think of the membrane of a drum if you just sort of hit that, you can kind of imagine there's sort of like a pitch element to it, like a tuning. Lots of drums have tunes. You can have big drums that sound real low and little drums that sound real high pitch. So there's a pitch element to it, and but the pitch is under tension, And so when you strike the membrane, you can sort of simulate that by taking the pitch of your oscillator and quickly dropping it. And it'll give the sort of impression of a sort of drum-like sound. We can't hear you, or I can't hear you. Did that?
Oh, am I not showing sound?
No, it's coming through.
Oh, it's coming through. Okay, yeah. I can't hear it.
I had to move it off the master so it wasn't repeating for Eric.
All right.
Okay, well, I've got, I did some work while you were explaining stuff, and I just want to quickly cover what I actually did here.
Yeah.
So since we added more knobs, I need to call this function library function for each one of them. So this is kind of the simplest way that I find to do that, is just to make an array and then call the single function on each element. And so assuming that I've done everything properly now, we've got our widget with knobs that go from 0 to 11 that are mapped 0 to 1 in the MetaSound itself.
Oh, I can hear that now, yeah. Yeah, so the other thing is noise. The noise element can add like an air to the sound. And you can get different kinds of sort of drum effects. Like you could get like a happy hardcore bass by like driving up the timbre with the wave shaper and having like a longer pitch mod. So the pitch decay, having that a little bit longer than normal, will sort of make it more synthy sounding. And then bring back the noise. And the noise will make it sound a little bit more natural. So you can kind of, so you've got these different elements, you can kind of tune them. Anyway, so what's cool about what Eric's done here is like, I think there were like 3 blueprint functions. You know, it's like pretty, like, look how basic that is. So now you can spend all your time making a beautiful interface. Right? Like,
that's right.
I'm over here grinning like an idiot because how cool that is.
This is awesome. Yeah.
It's so cool. We got somebody in chat saying, I know exactly what I'm doing as soon as this stream ends.
Yes.
I have to mess with these tools at least a little bit today.
Yeah, in the description there are links. You can find we've got the Fab link, I think, also, and then there's a link to our like docs landing page, and then we got 4 or 5 different. I don't remember how many docs. We've got a handful of docs, a fistful of docs, and tutorials, and some of them are pretty extensive. I know mine was like 20 pages. So,
well, what I just walked through on stream is covered in one of those.
Yeah,
pages.
That's awesome. Yeah.
If you want the text version of it, you can check it out there.
That's right.
Yeah.
Cool.
So cool.
This is awesome. Yeah.
Did we have any other content we wanted to show off?
We do. We have so much content. People are getting their money's worth on this stream.
I'm happy to run a little bit longer if you folks are.
Well, I think what would be cool is so this is a great example of. I mean, I ended up going into like Dan tutoring mode, but this is actually pretty fast to sort of stand up this preset widget. I think it'd be cool to maybe look, just sort of like take a look at the difference between a preset widget and editor utility. Like how do you use view models for editor utilities? And then I think we have maybe some light code examples to maybe direct people who are interested in maybe creating their own view models. What does that look like?
Sure. Okay. So yeah, let's look at the input migrator is maybe a little bit simpler. One thing that is pretty common throughout pretty much every tool that you use in the editor is that you want to have lists. And lists are very powerful. The other pretty common things are like buttons, lists, and then you have menus, which are lists of buttons, and it's basically those 2 things like all the way down. And so one thing I wanted to simplify or at least be able to reuse across multiple tools is creating lists of MetaSound inputs and outputs, and being able to quickly customize them and get them to do what I want. So in this tool example, where I had lists of inputs from 2 different MetaSounds, and then I was clicking on them to connect them and link them together is a little bit complicated in how that gets set up. And we can touch on some of that, but speaking honestly, I probably would flub my way through explaining some of the decisions that were made months ago at this point. But I can show what the view models are doing with regards to this tool. So view models, you can create your own custom ones in Blueprint. And if you want to make one that has editor functionality, you can inherit from the TechAudioTools editor view model class, which will let you do like all sorts of editor functionality in it. So what I did for this tool was created one called the MetaSound Member Migrator View Model. And in here, this is kind of like the brain of the whole tool. It kind of knows every aspect of it. And then for each of these lists, I have a whole separate widget. And each widget has its own list. And so the list gets its own view model. It actually gets two view models. One for the generic like overall TechAudioTools list view model, which is kind of a wrapper class. So when you pass items into list items, it's going to wrap each item with an entry view model class. And that's how you can kind of sidecar data into a view model that you want to use inside of your list entry widget. As you can see, like each of these rows in my list is for a MetaSound input. And if I show you what that one looks like, we'll start at the bottom is probably the simplest place. I've got kind of the basic stuff here where I'm actually binding the input name to my MetaSound input editor view model. And so this one is set to manual because it's receiving that input view model from the list. And then I can bind to the input name using the metadata for each of the inputs. And I can also bind to the default value. I can set the color of this circle. There's a function that lets you get the color of a MetaSound data type color. And if I pull open the view bindings here, you can see a lot of this is kind of extra stuff. Like I want to have like hover colors. So if I hover over the row in a list, it's going to change the color of the background. Or if I've clicked on it, I want to select a different color. And that's kind of what this style view model is for, which is kind of it's like a color palette of colors that I want to reuse throughout widgets. And they get passed along in the view model chain. View models all the way down.
It's a little bit of extra work, but I think that being able to sort of skin your
oh yeah, I think it's
cool,
really important. you want to have a user experience that people are comfortable using. Yeah. So if I run this tool and just show you, like we've got hover colors.
You got to dock it.
Oh shoot, yeah, good call. Yeah, so like it's really slick and looks really nice when you have like reactive, like if I hover over this row, it actually changes the text color in addition. All those small little things make a difference. And that's kind of where a lot of the complexity in the bindings come from. But you do it once and then, it's set up and you can copy and paste it somewhere else.
Yeah.
On the Blueprint side, this is the entire blueprint for that entry widget, which is really nice to not have to go in here and like create events or like on hover do something. Like everything's been kind of pushed into the view model where you just need to set up your bindings. I do have a conversion function here, which converts an object. If it's valid, we want to show it. Otherwise, we're going to hide that element. So things like that you can extend using the power of UMG View Model plugin. Very cool stuff. There's actually quite a bit of really good literature on YouTube for learning how to create and set up view model bindings. But yeah, I don't know. Is there anything specific you think I should?
I think that was a good little like micro demonstration of what it looks like to work. I think I feel like it just opens everything up when you talk about editor utilities. Like editor utilities are scripts that run in the editor that can kind of do whatever you want. And having a deep integration with MetaSounds, being able to access the graph in deep ways is very cool. And yeah, so I think that's exciting. And I think when we talk about like, yeah, you see the work that you've done with the view model bindings, but I feel like if you're again, we go back to that sort of like team acceleration kind of philosophy where it's like, oh, we're creating a tool that's going to save our team a lot of time. And so it's worth it, right? It's worth it. So
if I may wax a little bit on what the purpose of a view model is, and I think this is maybe a good a good illustration of that, it's a way to separate the data of your widget from the widget's implementation.
Right.
And so that makes it easier to swap out a knob widget for like a slider or something. You can create lots of different variations of a widget using the same view model without having to set up all of your blueprints and your data over and over again. And so in this list input, you'll notice that I have, there's a decent amount of blueprint work done here, but none of it has to do with MetaSounds. This is all having to do with the widget itself and how the widget operates, updating colors and when things are hovered and stuff. Like the MetaSound data doesn't care about any of that. Right. So that's kind of the separation of concerns here, is that your view models should be treated as the way to interface with the data, and the widget in the blueprint widget is where you want to focus on just the widget functionality, or like the logic or the behavior of the widget.
Presentation, etc.
Yeah.
So maybe this is a good segue into what does it look like to stand up a custom view model?
Sure. Yeah, I can. I did mention that you can do view models in Blueprint, but all the TechAudioTools stuff is in code. So I'm going to make sure I've got my code up. Yep. And let me switch over to that. Are we there?
Yeah.
Cool. Okay. So as mentioned, I think at the start of the stream, the MetaSound Viewmodels are in the TechAudioTools plugin in the engine as of 5.6. This is the 5.7 release, so there are some updates here. But as far as creating a view model, there's a few things that are maybe a little bit strange if you're coming from other types of creating other types of classes, namely in the uProperty markup here. You'll notice that all of these properties for, this is the MetaSound editor view model. So this has like all of the editor only descriptions and display names and things that don't matter at runtime. And for each one of these, they are protected, and which seems weird because then we have allow private access. So we're saying like you can't touch these things, but then, okay, allow private access allows us to modify them in Blueprint. And then we use the getters and setters as it's kind of a convention of a way to make sure that we're triggering the view model bindings, and that's responsible. Field notify is what's responsible for broadcasting those changes. So the idea here is that you define your property, you set it to field notify, so that way when this property changes, your widget will update. Then you define getter and setter functions. And in this case, I have a custom function name, so I have to specify it. If you don't have a custom function name, it's going to assume that you have a function called setAuthor. And I do have that down here. And so in these setter functions, I'm using this macro here, which will check if the value has changed. And if the value has changed, it will broadcast the field notify and update the UI. And so here I'm saying, if the value has changed, then we're going to get the MetaSound builder that we provided before when we initialized the view model, and we're going to get the document builder, and we're going to set the author. So this is how the view model interacts with the MetaSound builder itself. And we only want to do that when we know that the value has changed, just so we're not like constantly spamming updates.
Right. That's part of the optimization of view models, right? It's just
yeah. So like in UMG, the bindings that are like the legacy bindings, I guess, when you click on the little link icon for for each property that you can bind to, those are all, as far as I know, they tick, and they're pulling the data from elsewhere. So it can be very laggy in terms of performance if I have like multiple lists of inputs and like I'm scrolling on them and it's not smooth. That's because those bindings are ticking, and so view models will only call their broadcast if they have updated the property. So it's great for performance. It's great for making like modular, reusable data interfaces. I am a big fan of view models.
And they have you mentioned blueprints, so we don't have. I mean, we have to go in, but they also have field notifies, little bell icon, right?
Yeah, and maybe I can hop back over if we wanted to look at an example, because I know a lot of folks like using Blueprint. I like using Blueprint. So let me switch back over to my editor. So let's just go ahead and create a Blueprint class, and it's called MVVM Viewmodel Base. And so now this is not going to be an editor view model. Right. So you won't be able to access like editor only subsystems or editor function libraries, but it is the base class for all view models. And if I were to add properties, we get this little bell icon. And when you hit that, now you can whenever this property changes, if this Boolean variable is bound to like a checkbox or something, it's going to broadcast that field notify. Cool. I don't think I have any examples because everything in TechAudioTools is nativized. I think actually no.
Well, I think that's why all your Blueprint work is so lean.
Well, so I do have some view models here that I forgot I had. So let me find. Yeah. So here's like an entry view model. This one's specific to the tool. So in the input migrator, we have list entry widgets that you can link to one another. And so here's where I'm tracking which which input you're linked to. And then here's where I'm showing the default value. Let me go back to that just to demonstrate. So when this Boolean is checked, I have a list. Oh, yeah, thanks. So when I click on this, this is what's toggling this Boolean here. And when I have a linked value, and I guess this is the same asset, so I need a different one. It remembers that I had saved data. Whenever I have this link set, which is this property here, it's going to show that link icon, and then it's going to fetch the name of the input and show it as a tooltip.
So they're really modular. Like you've got like this one Blueprint that's just handling that little piece of functionality.
Yep. Yeah. So this view model goes on each one of those rows in that list. And then I have this as a way to get the input name and display it as the text on that widget. Cool. So yeah, there's a ton of stuff here for folks that want to go in and pick it apart and reverse engineer it or see how it was built. This is the big one. This is the main brain for the whole tool. So you can see by my number of tabs here that it's a bit crazy. The event graph is nothing though. Everything is a function that you can bind to. I've got variables that are all field notify, where I'm specifying different list view models, different inputs that are selected. If the save data is dirty and allows you to save it again, all that sort of thing has been implemented in here. The widget itself, if I come back here, we go to the graph tab. Again, like these are all just like operational things where if you click the button, we're going to call a function on our view model. And this could actually be set up as a binding. I wouldn't have to do it in Blueprint. But I'm still trying to find like what's a good like best practice around that. Like having a binding in here. Where'd it go? Like make some room here. I guess buttons would have one. So if I create a new binding, oh, you can't see it. Okay, so maybe it's good that we didn't go too deep into setting up bindings, but In here, you can set up. I'll set it so then you can at least see the result. You can bind to this on clicked event, and then I can call, if I find a function, I can call a function on my view model directly, and then specify the input parameter for it, and I can bind that to something else. So it's super powerful in how deep you can get with customizing the behavior of your tool, and like I said, the view models have all of the information for how to perform the tool's functionality. So that way, if I wanted to make a completely new widget, I wouldn't have to redo all of the tool logic. I would just need to redesign the widget and how it operates and functions with the view model, calling the functions into it and stuff.
Awesome. Thank you.
So
Yeah.
cool.
I know it's kind of heavy. It's
Yeah. No,
view
it's-
models are a pretty big topic, but
We worked up to it. It's fine.
yeah. You made it this far, so
Awesome. Do we have anything else we wanted to cover while we're here, or?
I think we should reward people with answers if they have
Oh,
any
yeah.
questions.
Perfect. Let's do it. So we do have a couple, and this is going to be a good reminder real quick. We know we're running a little bit long, but if you have any other questions for the team that we want to rapid fire at them real quick, just put in brackets question first, followed by the question, and we will get through them. Looking through the question sheet here, we've actually answered quite a few of them. Your
Nice.
demonstration as time has gone on has answered them. Like one of them was, can you export these as WAV files? Which
Yep.
yes, you can. The other one was, do any of these tools allow to see the waveform? And it looks like, at least in the synthesizer generator, there is ways of previewing that. So that's great.
By the way, the former question, if you look at the sound effect, you download it, get the plugin, download it. It's free. But if you look at the sound effects generator on the output, there is a right at the last part of the signal chain, there's a little node called the wave writer. And that's a node that lets you feed it audio while enabled, and it will output, serialize that to a wave asset in the saved content. So yeah.
Great. This is more like a general question. Is this more of an update for MetaSound, or sort of like an expansion / extension of its capabilities? And being a plugin, I would assume the latter rather than the former, but partly.
I mean, MetaSounds are updated all the time. So update your Unreal version all the time. Be responsible, I guess.
Get permission if you're working on a team, but yes.
But yeah, so this is like, and maybe Eric has a different framing, but to me, it's like a way to sort of get a deep connection to MetaSound data, and then make that available to the sort of authoring process and the editor sort of scripting tools. So.
Yeah, I see it as an extension of what's available in MetaSounds. The whole TechAudioTools ecosystem is kind of like our way of working with MetaSounds. But like, if you don't like the view models that we've provided, like, you can go and do your own setup. All of the stuff that we do in view models is built on what's available in the base engine. It's namely just built around the MetaSound builder, and there's another class called the builder delegate listener, which you can bind to and receive events for when people modify properties such as inputs or like metadata and stuff. It's all built around stuff from there, and you can, if you look at the code, you can see the parts of that we're using. But yeah.
We've unleashed this to the team on the wider like content team at Epic, and it's really cool to see some creative ways of both auditioning and authoring the MetaSound data. So it's like it is really like the utilities that Eric is they're very general purpose utility. That's great, but there's also sort of an argument to be made for like very specific things that are very particular to your project, and how you think, think about, when you're embarking on a project, you're coming up with these ideas, systems, and how they work, and music designs and weapon designs and who knows what else, crazy game. And so, thinking about how you can encapsulate workflows or help processes, this is sort of the domain here. And I think that the part of the extension is really making stuff accessible to a wider part of the content team. Like, look at this. Like, again, that sound effects generator. It's kind of a wacky, sort of playful example, but like, if you were to just give someone the graph, who maybe is not familiar with that area, or maybe not familiar with MetaSounds, they'd be lost, right? And so, having a sort of curated view on the data on the authoring process can help a lot. But also being able to automate script, batch script, all sorts of kind of stuff. You can kind of go to sky's the limit, basically.
Yeah. No, it's great. This one is kind of interesting. It says, I assume MetaSounds allows for MIDI inputs to drive its graphs. Would it also be able to be driven by an MPE source like an Expressive E Osmos?
So, so you saw that Eric's demo at the sort of sizzle reel, where he made for Game Sound Con last year, where he had his little mini
chord.
Mini chord, yeah.
Yeah.
And that was because, remember, think you have blueprints. So Unreal has MIDI device input and output support, and that is accessible through blueprints. So that's how Eric was controlling the MetaSound, was through the blueprints, the sort of intermediary layer. And so you have access to the data. I don't know how the MPE is breaking up the data across the port. Like, it uses all 16 channels of the MIDI port for a single voice. But it's all mapping. So you could get your input, set up your Osmos, and plug it in and see what happens. First of all, to see what happens. And there's a process of, like, when you've got a novel input, setting it up, like doing your print functions, checking, values, seeing what happens when you do this thing. The value wiggles here, that sort of stuff. But once you've got that, this is where you could create like some blueprint utilities that interpret your input data and then make it like become like a translation unit, basically, for whatever you want to do with the MetaSound.
Right. So even if it's not like inherently out of the box, there are ways to incorporate that data. Awesome. This one may or may not be a question that you folks can answer, but we had it come in a couple different times, so figure we'll throw it at you anyways. On the whole, how do you feel about MetaSounds as it is in 5.7 versus established middleware like Fmod and WWise and things like that? I saw another question here is MetaSound meant to like kind of take the place of an Fmod or WWise, or kind of work on the side or in tandem?
I have a lot of opinions about that. I don't know, Eric, if you've got anything. I feel like I'm dominating a lot of the answers here.
I mean, I can make one point, I guess, is that like MetaSounds is just a source.
Yeah,
it's just a source, and it's not the full. It doesn't define the full spectrum of what's available in the greater Unreal Engine audio engine. And so it's not quite a fair comparison. And maybe you want to talk about your part.
This is a little bit of the fault of Epic Marketing. I mean, Epic Marketing is really good, and when UE5 came out, like the number 3 bullet point was MetaSounds. And MetaSounds, largely, we have ambitions for incorporating MetaSounds into more of the audio engine, but there is a audio engine that is not MetaSounds, like is a full suite of features that is not MetaSounds. And so you wouldn't necessarily compare MetaSounds directly with middleware that is a whole audio engine on its own, right? Like Fmod and Wise are audio engines entire, right? And they have all these other features that you wouldn't necessarily implement inside of a MetaSound. And so And I think that maybe it's maybe a little bit confusing because MetaSounds it sort of presents itself as a dedicated audio space, right? Just like Materials, just like Niagara. But the work of a technical artist working in Niagara is not limited to the Niagara editor, right? Like they're working in blueprints, they're connecting things to gameplay. The space is fully integrated into the Unreal Engine. And so the same is to be said of audio. Audio, the audio development, audio engine development is inclusive of Unreal. It looks at Unreal and it says, okay, we have data assets, we have state machines, we have scripting, we have all these capabilities that we don't need to replicate or duplicate that functionality in like an audio specific space. We can incorporate audio into all these other spaces, and so that's the big difference. If you want to talk about the difference between working in middleware and working with Unreal Audio, it's where the audio is. In a middleware utility, a lot of the functionality is encapsulated in a sort of sandbox separated thing. Maybe that's your jam, but Unreal Audio is sort of got its roots into all sorts of different other places. And that gives us gives Unreal kind of an advantage, Unreal Audio, because we talk about this whole thing, by the way, everything we've been talking about today is about access to data, integration with data, right? Where the data exists, where we can affect it. And so when you think about, you need to convert information that is part of a game design or technical design or animation and that stuff, and you need to make that data available to your audio. Middleware has to use this sort of pipeline to sort of truck stuff out to the separate spaces, but we have kind of we can just sort of go in there and be like, here we are, we're audio, and we're going to just add audio to this. Like Niagara, you can spawn audio components. It's crazy. Like you can go. So I would say that's the sort of the fundamental difference. Now, with that said, part of Epic's philosophy is not to have walled gardens. We don't like that at Epic. We want to bring everyone to the table. And so we have a plugin that we developed called AudioLink, and we have partnered with middleware companies like AudioKinetic, like Firelight, to help them implement a tool that uses that. And AudioLink allows audio engine sources, renders, to get bussed outside of Unreal to middleware. So you can actually have audio, I think that's actually part of the Wise, as an example, I think it's part of the Wise Unreal integration deployment is this AudioLink for Wise plugin. So that's the paired plugin is you have AudioLink and then you have AudioLink for Wise, and then that allows Unreal sources to pipe out to Wise. So you can have your MetaSounds and you can have your actor mixer hierarchy at the same time, right? So yeah, so that's sort of, I would say that's what's going on here. And if you're still at OR, activate AudioLink and start playing around with both of them. So
yeah, awesome. Well, we have one more question here. This one may or may not apply again. Considering you developed the tools, I would assume you also developed a lot of these checkboxes, but we had somebody that wanted to know how many times when developing this plugin did you just mix a checkbox that had you pulling your hair out until you figured out what it was? And then...
Far too many times. I'm not too ashamed to admit that, because it's just one of those things in Unreal where there's checkboxes everywhere. That's always the first. If something's not working, the first thing I do is go check that box and see if it's not working. So if you run into issues with setting up these MetaSound preset widgets, check that box, because that's the kicker. Same with checking the creation method and and making sure that message isn't
player
appearing.
Context one.
Yep.
Yeah.
So use the documentation as kind of a nice reference to make sure that you checked all the right boxes and didn't miss anything.
A checklist for the checkboxes.
Checkbox checklist. Well, perfect. That is all the questions that we had in the chat. Like I said, you ended up answering most of these while demoing, so that was awesome. I did have one final one that I wanted to throw at you though, which is if you had to summarize this all down into one piece of advice or one tip or one thing you hope people try or use with these tools, which we covered quite a lot here, so this is like an impossible question. So I'm sorry, not sorry. What would you say for that?
I think we get 2, right? Because I did get one, and then Eric gets one,
Yes.
right? Yeah, nice.
You go first.
Okay. So I would say
I need you to narrow it down.
No, well, I think the main takeaway is installing like Unreal as it is not the end. Right? In other words, your ambition can be matched with the work to extend the tooling, right? This is all about extension. And so you start with something, and like people are like that. I think the middleware person is like evaluating like apples or oranges, and it's like this, like the vanilla is just the base, right? And so I feel like that's a massive takeaway from this is like your imagination is the limit to where you can take the tooling and take the design environment. So
I'll drive home the point that the tools that your designers, your sound artists are using will affect the output of their work. And so the tools that we provide them, the more ways we can shape the way that they're able to interact with their content and iterate and try new things, the better their output will be, or maybe it'll be more enjoyable for them to do it in the process.
Or focused or constrained, right? Like shaped, directed.
Awesome. Well, thank you guys so much for coming on here and showing off these tools. And thank you so much for staying a little bit later to finish the demo and answer the questions that we had in chat. This was really cool. As an audio nerd enthusiast, but not professional, I think these things are really, really fun. And I echo the sentiment of the folks in chat saying, well, I know what I'm going to do after this.
Yeah.
Because
download
these
it,
are really
plug
cool.
it.
Yeah, absolutely. Well,
yeah, that was fun.
Oh, sorry.
Yeah, thank you.
Yeah, no. That's going to wrap up today's Inside Unreal. Thank you again to all of our wonderful guests for coming on and demoing this stuff. And a huge thank you to everyone in the chat watching. This show would not be what it is without you, your questions, and your time. And if you came partway through the stream and wanted to rewatch a section, no worries. We post all the streams in video format that can be viewed on demand on our Twitch and YouTube channel at Unreal Engine. You can also keep up with the latest news, shoutouts, and other cool information on all of our socials at Unreal Engine. And if you haven't already, come join us on the Epic developer community, where we have our documentation, tutorials from both community and Epic staff as well, forums, and more, which you can also use to find the great documentation from these tools, which we will also, again, pin in the comment down below the VOD here. So if you want to check those out, absolutely do so. As always, on the VOD format, if you've watched the show later and you have thoughts, feedback, questions, any sort of thing like that, please use those comments. That's what they're there for. And we will gather these and get them to the folks, especially for feedback, to make sure that these tools do the best that they can and cover all the things that you want them to do. So that's pretty much it. So again, thanks everyone for watching. A huge thank you to the guests, and we will see you guys here a little bit later. All right. Bye, everyone.
Bye.